Okay, intermediate algebra practice final exam, page 6 and 7. Okay, number 20, we just want to subtract these two polynomials. Okay, so if we're going to subtract the two polynomials, we should distribute this negative and then just combine our like terms. Okay, so let's rewrite 3 over 4x squared minus 6 over 7x plus 4 over 5, and then when we distribute, it's just going to change the sign of every term in the parentheses. So minus 1/4 x squared plus 1 over 1/14 x minus 1/10. All right, so now we just combine our like terms. Okay, so this is number 20. Okay, let's see our like terms here. We have 3/4 x squared minus 1/4 x squared. So add their coefficients. 3/4 plus a negative 1/4. They have a common denominator, so that one should be easy. Just 3 minus 1 is 2 over 4. And then keep the variable the same. And then we'll just simplify that next step. Okay, let's see. What other like terms do we have? We have negative 6 over 7x and 1 over 14x. So I'm going to go to the side and do that work. Negative 6 over 7 plus a 1 over 14. Okay, to combine like terms, remember you simply add their exponent. Not exponents. You simply add the coefficient in front. The reason I wrote this to the side is because we do not have a common denominator, so it's not as easy to just do in our head, which means we need to get a common denominator. The LCD will be 14, so we can just multiply 2 to the 7 to get a 14. So we also have to multiply 2 to the numerator. So we have negative 12 over 14 plus 1 over 14 is negative 11 over 14. So when I add negative 6 over 7 plus 1 over 14, we get negative 11 over 14. So negative 11 over 14, and the variable's x. And then the last set of like terms, we have 4 over 5 and a negative 1 over 10. So 4 over 5 plus a negative 1 over 10. To get a common denominator, multiply 4 over 5 by 2 over 2. So that'll give us 8 over 10 plus negative 1 over 10. And that is 7 over 10. Okay, so we have plus 7 over 10. 2/4 is really 1/2. X squared minus 11 over 14x plus 7 over 10. Okay, so that is our final answer that we would type in. Okay, number 21. Multiply using the rules for the product of the sum and difference of two terms. Okay, so we have 4x plus 7 times the quantity 4x minus 7. These are conjugate pairs, so you can use the shortcut. If you forget the shortcut, well, you can just FOIL. But the shortcut is, since we have conjugate pairs, we would just do 4x times 4x, or just 4x squared. So that would be 16x squared. And then minus 7 times 7 is 49. Okay, and again, this is the shortcut. If you forget the shortcut when you're multiplying conjugate pairs, then just FOIL like you normally would. So 16x squared minus 49. And what would happen if you FOIL like normal, or the middle terms would just cancel each other out. All right, 22. Factor the following polynomial by grouping. So factor by grouping. Group the first two terms together, group the second two terms together. In the first two terms, they have a factor of a in common, so factor that out. So we're left with the b plus 7. In the second group, they have a factor of 2 in common, so factor a 2 out. And we're left with b plus 7. Now when we look at the a times the b plus 7, And then looking at the 2 times the b plus 7, they both have a common factor, b plus 7. So let's factor out b plus 7, and we're left with a plus 2. Okay, so this does factor, and it's equal to b plus 7 times a plus 2. Okay, and it doesn't matter what order. If you put a plus 2 times b plus 7, that's fine as well. The factors, it doesn't matter the order. Okay, 23, factor the polynomial, or factor the trinomial, which is a polynomial, it's just a special, it's just being more specific. Okay, so first thing I would check, can we factor a 3 out? No, we can't. So now we just try and factor this. You can either use the AC method. I use the trial and check because that's my preferred method. So what I do is, well, to get 3c squared, to get 3, the only factors we could do to get that is a 3 times 1. So I'll do my 3c and my c. Conveniently, 5 is also prime, so the only way to get 5 would be 5 times 1. And since it's a positive 5 here, this would either have to be a plus 5 and a plus 1, or a minus 5 and a minus 1. But that's where we look. Plus 16c means we know they're going to both be plus. Okay, so let's see if we do. 3 times 5 is 15, and 1 times 1 is 1. 15 plus 1 is 16. So we want to do 3 times 5. So 3 times 5, that would be the outers. So I know to place my 5 here. And I want to do 1 times 1. Okay, c, this would be 1c. So I want my 1 there. I always suggest checking after you factor. How do you check? Well, you just multiply them both together. Okay, 3c squared. 1 times 5 is 5. And then 3c times 5 is 15c. 1 times c is c. Add those together, we get 16c it checks. Okay. So 3c plus 1 times c plus 5. Okay, 24. Solve the equation. Okay, you should be able to tell that this is a quadratic equation because we have a square there. Okay, so when we want to solve an equation like this, we need to isolate everything to one side. So we want the z squared, the 14, equal to 9z. We want them all on one side, and we want 0 to be the other side. So subtract 9z from both sides. So that gives me z squared minus 9z plus 14 is equal to 0. And now I just need to factor. Okay. So this trinomial will have zz. And what factors to get a 14 will give us a negative 9. So to get a positive 14, it would either have to be 2 positives or 2 negatives. But to add to get a negative, it's going to have to be 2 negatives. So let's see. If we do negative 7 and a negative 2, that gives us positive 14. If we add these two numbers, it gives us a negative 9. So there we go. Okay, once you have this factored, set each factor equal to 0 and solve. So z minus 7 is equal to 0. Or z minus 2 is equal to 0. So we have z is equal to 7. Or z is equal to 2. So the solution set is A, 2, 7. Okay, we have 25, multiply and simplify. Okay, sounds good. Let's multiply and simplify, but before you multiply, remember when you multiply rational expressions, you multiply their numerators, you multiply their denominators. But you should always simplify before you actually do any multiplying. And in order to simplify, everything must be factored. So let's work with 36x minus 8. Well, there's a factor of 4 in common here. So if I factor out the 4, we'll have 9x minus 2. Okay, so the first numerator, 4 times 9x minus 2. And 9, it's just a number, so just keep it 9. Times, again, 6. And then if you notice how 36x minus 8, one of the factors of that is 9x minus 2. It looks very similar to 2 minus 9x. When you have something like that, try factoring a negative 1 out. So if we factor out a negative 1, that would just change the sign. So if I move out the negative 1, then we'll have a negative 2 plus 9x. Is 9x minus 2 the same as negative 2 plus 9x? Yeah, they are the same factor. Because remember, you can move the terms around. If I move the position of the negative 2 and the 9x, then that would say 9x minus 2. So we can cancel out those factors. See, a 3 goes into 6 2 times, a 3 goes into 9 3 times. I don't see any other factors in common. So now multiply the numerator. 4 times 2 is 8. Multiply the denominators. 3 times negative 1 is negative 3. Notice that's fully simplified, which I would just write it as negative 8 over 3. So it's simplified all the way down to negative 8 over 3. Okay, moving to page 7. Okay, so 26. Divide and simplify. So when you divide fractions, remember you always keep change flip. You turn it into multiplication. Same thing with rational expressions. So keep 2x over 3. Change division to multiplication. And then you flip, which is the same as just getting the reciprocal. So 3x plus 6 over 4x plus 8. And now we'll do the same thing like we did with 25. Factor everything first, cancel out like factors, and then multiply. So let's see, 2x is factored, 3 is. We can factor out a 3 here. So that would be x plus 2. We can factor out a 4. So that would be 4 times x plus 2. Now cancel any like factors. We have 3's in common, x plus 2 in common. And then 2 goes into 2 once and into 4 2 times. Let's multiply across the numerators. We have a 1 and an x left, so that would just be x. And in the denominator, it looks like we only have a factor of 2 left. So this is x over 2 is what it simplifies to. Okay, 27. Perform the indicated operation. We want to subtract these two rational expressions. In order to add or subtract fractions, you need a common denominator. And same thing with rational expressions. In order to add or subtract them, we need a common denominator. In order to find a common denominator, we must factor the denominators first. So let's factor. This is going to be y plus 3 times y plus 4. And this is y plus 3 times y minus 3. So the LCD is going to be y plus 3, y plus 4, and y minus 3. Okay. So the first denominator, we have y plus 3, y plus 4. We're missing y minus 3. So we'll multiply the numerator and denominator by y minus 3. So y plus 3, y minus 3 over y plus 3 times y plus 4 times y minus 3. Okay, see, this was the first expression, just with the y minus 3 over y minus 3 multiplied to it. Here's my minus. And now y plus 3, y minus 3 is the denominator. It's missing the y plus 4, so we'll multiply y plus 4 to the numerator and denominator. So 5 times y plus 4 over y plus 3, y plus 4, y minus 3. Okay, now that we have a common denominator, we can combine the numerators. I need a little bit more room, so let me add this paper here. 27. Okay, so I can combine the numerator, y plus 3 times y minus 3 minus 5 times y plus 4 all over the same common denominator. So that's a y plus 3, y plus 4, y minus 3. Now we need to simplify the numerator and then see if we have common factors. Remember, you can't cancel anything out yet because of this minus separating these two terms. So we can't cancel anything yet, but we will have to FOIL this, or if you notice they're conjugate pairs, use the shortcut y squared minus 9, and then you'll have to distribute the negative 5 into this set of parentheses here. So minus 5y minus 20 over the LCD. All right. And now combine any like terms in the numerator, which we have just a negative 9 and a negative 20. Y squared minus 5y minus 29 over y plus 3, y plus 4, y minus 3. Okay, can we factor y squared minus 5y minus 29? Well, 29 is a prime number, so the only factors would be 29 and 1. And we cannot subtract those numbers to get a 5 or to get a negative 5 in any way. So the numerator is not factorable, which means there are no factors in common, and this is the final, okay, our final answer. So this, I don't really have much room to write it here, but I would just type in y squared minus 5y minus 29 over y plus 3, y plus 4, y minus 3. And again, the factors in the denominator can really be in any order, okay? As long as you have those same exact 3 factors. Okay, 28. Simplify the complex fraction. Okay, again, there are many methods you can use for these types. I like to multiply the full numerator and the full denominator by the LCD. And the LCD, if we have an x and an x squared in our denominators, would be x squared. So x squared over x squared. Okay, distribute the x squared. So that would give us 3x plus 7x squared. Okay, and then over distribute the x squared in the denominator. They give us 9 minus 49 x squared. Okay, and then we want to see if we have any common factors in the numerator and denominator. In the numerator, we can factor out an x if we like, which would give us 3 plus 7x. In the denominator, that is actually the difference of squares, and we would use our shortcut rule to factor difference of squares. It would be 3 minus 7x times 3 plus 7x. So this actually does simplify more because we have a 3 plus 7x in the numerator and denominator. We have x over 3 minus 7x. Okay, and that's the final. Okay, the next one, divide. So we want to divide. The point is to divide using long division. Okay, so I would set this up with long division, the x plus 5 into 3x squared plus 19x plus 20. Okay, and for long division, we take the first two terms of the divisor and the dividend, and we see how many times x will evenly go into 3x squared. So it's always easier if you put it over to the side, so you don't, it just makes it more visual, less likely to make a mistake. So that would be 3x times, so we can write that up top. Now multiply. So that's 3x squared, and then plus 15x. We're subtracting, so distribute the negative to both of these terms, and then we can add. Okay, 3x squared minus 3x squared cancels. So I just put a little happy face because we're happy that that happened. And then 19x minus 15x is 4x. Bring down the plus 20 and we repeat the process. So looking at the first two terms, how many times does x evenly go into 4x? That would be a positive 4 times. Write that above and then multiply. So 4x plus 20, change the signs, and everything canceled out, so there's no remainder. So 3x squared plus 19x plus 20 divided by x plus 5 is 3x plus 4. Okay, number 30. Solve the following equation. Okay, that's a rational equation because we have rational expressions there. Let's get another piece of blank paper so we have extra room. Okay, so this is 30. And it's 2 over x plus 3 minus 4 over x plus 1 is equal to negative 2 over x squared plus 4x plus 3. Okay, so what we want to do is find the LCD of all the fraction expressions, and then we want to multiply both sides of the equation by that LCD to clear all the denominators. X plus 3 is factored, x plus 1 is factored. This is not. Let's factor. That would be x plus 3 times x plus 1. And now the LCD is x plus 3, x plus 1. So we'll multiply that to both sides of this equation. Okay, so x plus 3 times x plus 1 times all this. And then x plus 3 times x plus 1 times all of this. And now we just simplify each side of the equation first. So we'll distribute x plus 3 times x plus 1 to 2 over x plus 3. The x plus 3's will cancel and we're left with 2 times x plus 1. Now distribute that to the negative 4 over x plus 1. The x plus 1's will cancel and we're left with negative 4 times x plus 3. Over on this side, we can just cancel out the x plus 3's and the x plus 1, and we're left with negative 2. Right, now it should look pretty easy because we cleared the fraction, and we'll just solve this linear equation that's left. 2x plus 2 minus 4x minus 12 is equal to negative 2. On the left side here, combine your like terms. 2x minus 4x is negative 2x. We also have a 2 minus 12 is negative 10. It's equal to negative 2. Add 10 to both sides. Negative 2x is equal to 8. Divide by negative 2. And we have x is equal to negative 4. Okay, so we do have to check the negative 4 with the denominators. So since x plus 3 is a denominator, we know that can't equal 0. So if we do negative 4 plus 3, doesn't equal 0, that checks. We have x plus 1 as a denominator, which can't equal 0. If we plug in the negative 4 plus 1 doesn't equal 0, so that checks. And then it's just a repeat of the same denominators we checked, so we know this is our solution. It checks. So the solution set is -4. All right, and that concludes page 6 and 7.